Welcome back to session 17 of GED Science Mastery. I am glad you are here. Heat is everywhere, in cooking, in the weather, in your own warm body. The GED expects you to do two things: tell the difference between temperature and heat, and know the three ways heat moves from place to place. And here is a bonus. These ideas come back when we study weather and climate, so learning them now pays off twice. Let's warm up. Here's the big idea in plain words. Temperature measures how fast the particles inside something are jiggling. The faster they move, the higher the temperature. Heat is different. Heat is the energy that flows from a hotter object to a cooler one. And heat always travels in the same direction, from hot to cold, until both objects reach the same temperature. So temperature is about motion inside one object, and heat is about energy moving between objects. Let's make the difference crystal clear, because the GED loves to test it. Imagine a tiny spark in a huge pot of warm water. The spark can have a very high temperature. Its few particles move incredibly fast, but it holds very little total heat energy. The warm pot has a lower temperature, but far more total heat because it has so many particles. So a high temperature does not always mean a lot of heat. Temperature is the average speed of the particles. Heat is the total energy that actually transfers. The first way heat moves is conduction, heat traveling by direct contact, passing from particle to particle. When you put a metal spoon into hot soup, the fast-moving soup particles bump the spoon's particles, which bump the next ones, and soon the whole spoon heats up. Conduction works best in solids, and especially well in metals, because their particles are packed close and pass energy along easily. So whenever two things are touching and heat moves between them, that is conduction. The second way is convection, which moves heat through fluids, liquids and gases. When a fluid is heated, it expands, becomes less dense, and rises. Cooler fluid sinks to take its place. That circular motion is a convection current, and it is what stirs a pot of boiling water and drives our weather. The third way is radiation, heat carried by waves that need no material at all. That is how the sun's warmth crosses the empty vacuum of space to reach the Earth. Contact, currents, or waves. Conduction, convection, radiation. Let's read a real GED-style experiment. A student dropped a hot metal block into a cup of cool water and recorded both temperatures every 2 minutes. Look at the bars, which follow the metal. At 0 minutes, the metal is 90 degrees and the water is 20. By 2 minutes, the metal has cooled to 60 and the water warmed to 35. By 4 minutes, 45 and 42. And by 6 minutes, both sit at 43 degrees. The metal keeps cooling while the water keeps warming until they meet. Let's answer with our method. Which way did heat flow, and what does the final row show? Read. The metal cooled from 90 down to 43, and the water warmed from 20 up to 43. Choose. Since the metal lost heat and the water gained it, heat flowed from the hot metal to the cool water, hot to cold, exactly as expected. And by 6 minutes, both are at 43 degrees, so they reached thermal equilibrium, the same temperature, with the net flow of heat stopping. Check. Heat never flowed from cold to hot. The two simply met in the middle and stayed there. One more useful pair, conductors and insulators. A conductor is a material that lets heat move through it easily. Metals like copper are excellent conductors. An insulator is a material that slows heat down. Wood, plastic, foam, and even trapped air are good insulators. This is why a metal pot heats up fast, but its handle is often plastic or wood, so it stays cool enough to touch. And it is why oven mitts are thick cloth, not metal. The insulator slows the heat before it reaches your hand. Let's lock in the traps. 1. Thinking temperature and heat are the same. No. Temperature is particle motion. Heat is the energy that transfers. 2. Thinking cold flows into warm things. No. Heat flows from hot to cold. Cold is just less heat. 3. Thinking radiation needs air. No, radiation crosses empty space, which is how sunlight reaches us. 4. Thinking metals are insulators. No, metals are excellent conductors. The recap. Heat always flows hot to cold by conduction, convection, or radiation until equilibrium. Wonderful work today. You can now tell temperature from heat, name the 3 ways heat moves, and explain thermal equilibrium. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory, and for each scenario, ask yourself, is this conduction, convection, or radiation? To read the full lesson notes and practice more GED Science questions, visit the course page at www.bridgetoexam.com. I am proud of your progress. I will see you in session 18, where we explore forces and motion, speed, acceleration, and Newton's laws. Keep going. You are doing great.